Hello everyone. Let's see the next CPU scheduling algorithm, round robin CPU scheduling algorithm. So before this, I already discussed the FCFS, SJF and SRTF scheduling algorithm. Okay. So it is the fourth scheduling algorithm, and in this round robin scheduling algorithm, we used a concept called time quantum. Time quantum. Time quantum means before running the processes in the operating system, we have to decided a time for which we run each process equally. Okay, so it is the time based on which we run the based on which we run all the processes equally. Okay, so for one time quantum we run one process, for next time quantum we run second process, and so on. So this particular concept will go on. Now, so this is the particular flow diagram which will represent the round robin algorithm. So in the ready state, we pick a process, okay, and the process pickment is generally based on the arrival time. So from the starting point, we pick the process which comes early, okay, and then after picking the process, we just compare their burst time with the given time quantum available. Okay, let's say the time quantum given is 3 unit, okay, and if process burst time require 6 unit, then we will compare these two factors. One is the burst time and the next is the time quantum, and if burst time is less than or equal is less than time quantum, then we will run this process till its completion, and after its completion we simply terminate the process. Okay, so this is a very smooth way of running the process. But if this time quantum is if this burst time is greater than the time quantum, then we will execute the process for exactly 1 unit of time quantum. Here 6 is greater than 3, that means we will run this particular process, let's say pi, we will run this particular process for exactly 1 time quantum, which is 3 unit of time, and after the time quantum expire, we will check whether this particular process is completed or not. If this particular process is completed, then again we will terminate the process. Otherwise this process will go on to the ready state again, and then it will repeat the procedure, it will do the same task again. Okay, check the burst time with the time quantum. If the burst time is less than the time quantum, then we will run it till completion and terminate it. Otherwise we will run for 1 time quantum exactly. Okay, so here criteria is, in this particular algorithm, the criteria for picking a process is, one is time quantum and the other is arrival time. So there are two particular criteria used in round robin. One is time quantum and one is arrival time. Why arrival time? Because whenever we start running a process, so all the processes initially will present in the ready state, and starting from initial point, the only factor to choose a particular process is the arrival time, and then after the time quantum comes into picture. Okay, now mode is preemptive. Why preemptive? Because we will run the process for exactly 1 unit of time quantum. So definitely here process will halt for some time and then other process will come. So mode is preemptive. And what is the data structure used? The data structure used in this round robin algorithm is Q. So Q is the suitable data structure for round robin algorithm. Okay, and one more thing, this particular algorithm, round robin algorithm, is comparatively compare or equal to the first come first serve round robin algorithm, first come first serve scheduling algorithm, because in first come first serve scheduling algorithm we also pick the process based on the arrival time. Okay, so it is somewhat similar. If we increase the time quantum to, let's say, infinity, then it becomes first come first serve. Okay, so let's see the analysis factor in later on videos. First we will see the examples. So in the next video, we will see an example related to round robin algorithm.